Bismillahirrahmanirrahim. In the last part, we spoke about the sample space and the probabilities. And we said that the sample space is the all listing or the set of all possible outcome of the probability experiment. For example, if we speak about the rolling 2 dice, we will have 36 outcomes. If we speak about rolling 2 coins, we will have 4 outcomes: head, 2 heads, 2 tails, head and tail, tail or heads. Listing all the possible outcomes, we call it the sample space. Now, in this part, we are going to speak about an event, simple event and compound event and the classical probability. Let's start with the definition of an event. An event consists of a set of outcomes of a probability experiment. The set of outcomes. It can be the whole sample space or just subset of the sample space. We have 2 types of events: simple event that consists of a single event, and compound event which consists of more than one event. For example, rolling 2 dice and getting 1 boy in set of or a family kids, or throwing 2 coins and getting even number on single die. So compound event that consists of more than one event. For the probability, we have 2 types also. We have a classical probability that uses sample spaces to determine the numerical probability that an event will happen. If we are using the sample spaces, we call this as a classical probability. If we are using the frequency that will be discussed later on, we call it empirical probability. And we have something called the equally likely events. Equally likely events are events that have the same probability of occurring. For example, if we throw 1 coin, the coin has 2 faces. It has head or tail. Head or tail, they have the same chance to display, 50% for each one. And since it is 50% for the head, 50% for the tail, we call this as equally likely events, if all the outcomes have the same probability of occurring. So we say it is equally likely events. The probability of an event E is given by P of E, which is equal to the number of outcomes in E. N of E, the number of the outcomes divided by the number of the outcomes in the sample space. This is the P of E. Number of the outcomes in the event divided by the number of outcomes in the sample space. To explain this, let's have some examples. If 2 dice are rolled, then find the following probabilities. First one, getting double. E, getting double. I have 2 dice. Getting double means having the same outcome in the first die and the same in the second one. So it is 1 in the first one and 1 in the second one, or it is 2 in the first one, 2 in the second one, or 3 and 3, 4 and 4, 5 and 5, 6 and 6. So this is getting double. And you can see that we have 6 outcomes. N of E equal to 6. And N of S, sample space, I have 2 dice. Each one has 6 faces. So it is 6 faces. And since there are 2, so the power is 2. 6 to power 2, which is equal to 36 outcomes. So in the sample space, we have 36 outcomes. Now we can find P of E. That will be equal to N of E divided by N of S, which is equal to 6 divided by 36, which is 1 over 6. So the probability of getting double is 1 over 6. Second one, sum of 8. Just write, list the E. Sum of 8 will be 2 and 6, 6 and 2. We have 3 and 5, and 5 and 3. And we have 1 time 4 and 4. So it is 2, 6, 6 and 2, 3, 5, 5, 3, 4 and 4. So in this case, the probability of getting sum of 8 is equal to 5 number of outcomes in the event E divided by 36. So this is the probability. 5 over 36. Next one, our event is 2 even numbers. Even numbers means 2, 4, 6. So to get 2 even numbers, E is equal to 2 and 2, 2 and 4, 2 and 6. Now 4 and 2, 4 and 4, 4 and 6. Also we have 6 and 2, 6 and 4, 6 and 6. So this is the list of the even numbers. So our events consist of 9 outcomes. In this case, the probability of getting even numbers or 2 even numbers will be number of the outcomes, which is 9 divided by 36. That will be 1 over 4. So the probability of getting 2 even numbers is equal to 1 over 4. In this part, not getting double. Not getting double means all the outcomes except the double here. You can see that I got 6 doubles. So the remaining will be 36 minus 6 is equal to 30. All the other outcomes. Not getting double. So let me say this is B of not getting double is equal to 1 minus probability of getting double. We say this is the complement. We say it is the complement. It is the other set. The other set. Or the remaining of the sample space which is not included in the first event. So not getting double, it can be found by saying it is 1 minus B getting double. It is 1 minus getting double. We say it is 1 over 6. Or it is 6 divided by 36. It is the same. which is equal to 36 minus 6 divided by 36, which is equal to 30 divided by 36, or divided by 6 up and down, it is 5 over 6. So not getting double means we are counting on the other outcomes which are not double. Removing the double from the sample space, the remaining will be 30 outcomes. So the easy way is to say it is 1 minus probability of getting the double. And this is known as the complement of event. The complement of event E is the set of outcomes in the sample space that are not included in the outcomes of event. I have sample space and we have event. The complement will be the outer part. This is E. And bar means the complement. We denote it by E bar, means the complement consists of all the outcomes that are not included in the event E. And the probability of the complement B of E bar equal to 1 minus B of E, or B of E plus B of the E complement equal to 1. Because if we add E with E complement, we get S, or union, let's say union. We get S, and this will be B of S. 1 equal to B of S. That consists of the E and E complement. So sometimes we use the rule of the complement event to find the probability because it is easier to count or to calculate. Here is another example. If 3 coins were rolled, then find the following probabilities. Getting 3 heads. So in this case, I have E equal to head, another head, and another head. So N of E is equal to 1. And N of S the sample space consists of 3 heads. We are throwing coins. Coins have 2 faces. Each coin has 2 faces. And since there are 3, so it is 2 to the power 3 is equal to 8. So N of S equal to 8, which means now P of the event E getting 3 heads is equal to 1 over 8. P of E equal to 1 over 8. Now in this, the second part, not getting any head. Not getting any head. It means all of them are tails. So not getting any head in this case this means all tails. Will be tail, tail, and tail. So in this case, P of E equal to 1 over 8 again. This is 1 over 8. C getting at least 1 head. This is 1. Getting at least 1 head. It means 3 heads or 2 heads or 1 head. At least means head, 1 head or more. When you see this word, at least one head, it means greater than one head. Greater than or equal to one head. It means I will get one head, or two heads, or three heads. Now getting at least one head, it is like, or this is the complement of not getting any head. So if E is equal to getting one head, or getting at least the complement for this one will be not getting any head. This is a complement, not getting any head. So we can use the complement rule to find the probability. This will give me B of E equal to 1 minus B of A complement. That is 1 minus not getting any head. We found it in the last part. It was 1 over 8. So the answer will be 7 over 8. So the answer of getting at least one head equal to 7 over 8. Just to confirm this one, E will be H, H, and H, or head, head, and tail, or it is head, tail, and head, or it is head, tail, and tail, or it is tail, head, and head, or it is tail, head, and tail. These are, or it will be tail, tail, and head. And you can see these are 7 outcomes. So the probability will be 7 over 8. This is the meaning of getting at least one head. It is one head or more. Now let's speak about the rules of the probability. From the last examples, we saw that all the value of the probability will be between 0 and 1. 0 if it is impossible to happen. For example, if we are throwing a die, what is the probability of getting number 7? There's no 7 in the outcomes. So the probability of getting 7 is equal to 0. Now, probability of getting numbers between 1 or from 1 to 6 is equal to 1. So the probabilities of, or the values of the probability will be between 0 and 1. There is no negative value for the probability, and there is no values greater than 1. Should be between, or must be between 0 and 1. The sum of the probabilities of all outcomes in the sample space is equal to 1. P of E equal to 0 if E cannot occur, and equal to 1 if it is 100% will be there or occur. Now the second type of probability, this is not probability, this is a probability. Using frequency of occurring an event. Given a frequency distribution, the probability of an event being in a given class is P of equal to F divided by the total frequency. If we are using the frequency distribution, we call it empirical probability. And this is based on observation, not over theoretical calculations. We are doing a real experiment. From the outcomes, we can calculate the probability for some events. So we are doing some observation or some real experiment, recording the outcomes, organize it, put it in a frequency distribution, then we calculate the probability. For example, given the frequency distribution of blood types, we have A, 15 people, B, 20 or 12, AB, 25, O is 9 people have blood type O. Find the following probability. P of A. We go back. It is the frequency divided by N. So P of A is the frequency, which is 15, divided by N. N is the total of the frequency. We have 15 plus 12 is 27, plus 25 is 52, plus 9 is 61. So P of A equal to 15 divided by 61. It is the frequency. Again, this is frequency divided by N. The total of the frequencies, which is equal to 15 of A divided by 61. P of O, we have 9 divided by 61. P of not AB. Not AB means just cross AB. The remaining will be the probability of the complement. Not AB means we are speaking about the complement of AB. It means the remaining outcomes or the remaining frequencies. If we remove 25, it will be 36 divided by 61. Other way, I will say 1 minus, or it's equal to, say, we use a complement, 1 minus B of AB. Not AB, we can do it by using the complement, which is equal to 1 minus AB is 25 divided by 61, which is equal to 36 over 61. This is using the complement rule. The B of A or O. A or O, this is compound event. Consists of more than one event. I have two events. A, this is one event, and O is another one. P of A or B, and this will be discussed in detail later on. This is equal to the sum of A and O. So it is like B of A plus B of O, which is equal to 15 over 61 plus 9 over 61, which is equal to 24 divided by 61. 24 divided by 61. It is the sum of, go back, sum of O and A. That is 24 over 61. More detail will be given about the compound property later on. P, neither A nor AB. It means not A and not B. So it means I will cancel A and AB. Not A means it is not there, not AB. So it is 12 plus 9. The remaining, the complement for this one will be B and O. So in this case, it is 9 and 12. So neither A nor AB, it means B of getting P plus P of getting O, which is 12 over 61 plus 9 over 61, that will be 21 divided by 61. So this is the probability of getting neither A nor A, B. It means you are looking for the other outcomes, which are B and O. And the probability will be 21 divided by 61. It is the sum of P of P plus P of O, which is 12, plus 9 divided by the total number of the frequency, which is equal to 61. It's 21 over 61.